Now in 2.6, we have absolute value inequalities. Now what we've seen in comparison of the two, right, inequalities and equalities, pretty much everything is the same. It's just that if you ever have to divide or multiply both sides in the end by a negative to make a phantom 1, then you just flip the inequality. But there's something to that, by the way, the negative thing, which we're going to see with this inequality stuff that breaks it up. So, right, in the last lesson we said, hey, look, absolute value of x equals 3, then you break this up into 2 separate equations. We're going to be doing the same thing even when there's an inequality, but there's just one small catch there. But again, principles of equality will still apply, because, and here's why, is because where we find the equation gives us equality, that's where it switches from being true to false, okay? So, and we're not really too concerned about that, although in 10.10 they will expand on that a lot more, okay? But for now, all we need to do is know that the equality, that's where it changes from true to false. And yeah, we'll have an open or closed circle, and then whether it eats the x or not, that will determine if it goes left or right, okay? But principles of equality, just whatever you do to one side, you got to do to the other side. So yeah, solving equalities, nothing new here. Distribute, combine like terms. Sometimes neither of those are necessary, sometimes only one or both. Principles of equality, to isolate your variable, divide both sides by the coefficient. And again, if that coefficient's negative, then we flip the inequality. And again, that hopefully helps us to see that nothing's new there. All right, so on this one, you may want to use the number line. What does it say? What values of x would make the following statements true, and why? Well, I don't know that we really have to answer why, but here's the thing, right? You say the absolute value of x, it has to be less than 5. And so, yeah, number line, it's true, it may be helpful. So let's just 0 right here in the middle, 5 here to the right. Now, we know that if you chose 5 and replaced it as x, it would be false, right? And so we know that, x could be less than 5 right here. So anything less than 5 should work. Anything, and I'm going to 0 on purpose. Some of you know what's going to happen right here, right? But we know absolute values are going to punch out a negative value for us, which would still be true. So if I went all the way to the negatives, and I am putting -5 here on purpose, any of these values in between 0 and -5 would also give us a true statement. So I'm going to extend that line over here. But once you get to -5, if you replace -5 in for x, hopefully you can see there that would result in a false statement. And so we got to have an open circle there at -5, okay? Now, what does this do for us? Well, it's kind of a quick introduction on what's going to happen, although nothing really changes except for, like I said, one minor issue, right? So we're going to take this inequality, we're going to split it up twice. We're going to compare with x, in this case, with 5 both times. And the first statement is always just the regular statement without the absolute values. So for this one, it'd be x is less than 5. Hey, there's one statement that would be true, okay? The other statement would compare x to -5. But remember, and I've just kind of, it's not that I've arbitrarily changed that x or the 5 into a negative. It's because I've just went from 5, I went on both sides of 0 here, right? Because everything in between should give us a true statement, but it ends at -5. But now I need x to be greater than 5. See that? So, well, I'll say the purple statement. I'll make this one green. Okay, so that would be this statement right here, right? And then I'll do this one in orange. So it'd be open circle and to the right, but you can see that's where they would connect right there. Now what this also means, and this is kind of what the next slide gets. On this one, we can see that, and just this one right here is like the one we just saw, okay? If you see that an absolute value is less than some value, then it gives you kind of that intersecting compound inequality and statement right here, okay? If by chance it was eating that I'm going to start that over, sorry. If by chance it were eating the absolute value, if the inequality is eating the absolute value, then we see it becomes an or type statement right here. So that's shown right here. This first one is what we've already seen. Just, we never really looked at it with a graph. But yeah, well, I guess we kind of did. But yeah, if you have the absolute value equals a value, then it gives you 2 different values, the positive and the negative, the opposites of those, okay? Now, of course, in the future here, we're going to expect not to see just x's inside the absolute values, right? You're going to see something like 2x plus 5, 9 parentheses, 8x plus 21. I don't know, whatever, all right? And by the way, what you're seeing right here is it's purely algorithmic, okay? It's just a pure rule. You have to memorize this. Not. I would say no. Okay, and I'll explain why here. If you think about the problem we just barely did, hopefully it will kind of make sense. The reason why I feel like I have to show this is because of this next problem. So on this one, right? This one, which you're going to see a problem like this on the homework. I mean, you got two options. And from what I remember, I don't remember seeing anything like this on an exam. But that was a long time ago. So which of these would be true? Would this give us an or statement, this inequality here? Is it an or statement like B? Or is it an and statement, a compound inequality like A? Well, like I said, from the first problem that we did, this really results, so let's show this over here. Absolute value of x is less than 15. Remember, you're going to break this up into two now inequalities, right? You say, well, just keep it as is, but without the absolute value. And then compare x with now not just 15, but its opposite, so negative, and then flip the inequality like this. Now, I didn't put a statement between there because I guess the graph kind of emphasized that, but what you can do is you compare this from least to greatest, 15 and 15, negative 15 and 15, and we see this first statement right here, it's eating the x, so it would have to keep eating the x, and if I compounded that here between x and 15, it would have to eat the 15 right there, which means that this is an A-type problem. However, if you had memorized the stuff that we saw on that last slide, you'd be like, oh, it's A, and I know it is A, and that's fine. Again, if it does not eat the absolute value, it becomes this compound inequality and statement. If it were to eat the absolute value, it would become an or statement. That's the difference. So that means on a problem like this, you could say, hey, look, this one is eating the inequality, the absolute value, rather. The inequality is eating the absolute value. So you could split this up into an or statement. Fair enough. Like I said, we don't necessarily need that. And yeah, we'll write this in interval notation, right? So I'm going to split this up into two separate inequalities. 5x minus 8. If I just get it to be greater than or equal to 9, that'd be true. Then I'm going to compare the absolute value, which is 5x minus 8, with the opposite of what we're comparing with, now negative 9, and flip the inequality, okay? You're perfectly welcome to put an or statement right here if you'd like. Well, now we're looking at a problem that we saw, essentially problems that we saw from last time, except for, of course, they're very close to each other, right? So what is this, 2.6? So this would have been, takes us back to like 2.4 kind of stuff. So let's go and solve. And, all right, so add 8 to both sides. That's not what I wanted. There we go. Add 8 to both sides of both inequalities. So I'm doing this kind of fast on purpose because we've already seen this several times. You practiced it on the homework, and we got to get through the review as well, okay? In any case, that's going to zero out my negative 8s. I'll drop my 5x's. This one now is greater than or equal to 17. And when I drop this 5x, it's less than or equal to negative 1. Divide both sides of both inequalities by 5. So x now is greater than or equal to 17/5. And this one, divide by 5. X is less than or equal to negative 1/5. And yes, this is still an or statement. So when I go to my graph, and yeah, we'll write this in interval notation. And the graph doesn't have to be perfect. 17/5, I'll just put it way over here. And then negative 1/5 somewhere in this area, okay? So 17/5, close circle, it's eating the x, boom, to the right. Negative 1/5, close circle again, because again, that's equal to the x. So it's close circle again. I'll make that look a little bit prettier. It's not eating the x, so it goes to the left. So there's our graph. And now I'm doing the graph really for my sake. I don't know about you. But I like to see the graph so that I can visualize the interval. All right, so starting as far to the left as I can go, this first green line goes to negative infinity. It stops at negative 1/5, which is included, so that's going to be a square bracket. I'll unite this with starting at 17/5, moving to the right. That's included, so square brackets and infinity. So we get this or statement like this with the union, and it's okay to have the fractions in there. And again, I only did the graph because it helps me. I hope it helps you too, okay? All right, here's our next problem, and I'm purposely doing this very fast on purpose, okay? So we're going to split this up. 3x plus 25, got to be greater than or equal to negative 9, and then 3x plus 25, 25 is less than or equal to 9, because I took the opposite, right? Now I'm doing this, again, purposely fast on purpose, and you do some work here, and you do some work there, you're going to find that x equals something, or it's greater than or equal to something, or less than or equal to something. If you go that far on this problem, you've gone way too far. In fact, the moment you've done this, you've gone too far, okay? Some of you notice what happened right here. Well, let's look. See this absolute value? I don't really care what's on the inside, but it's saying the absolute value is greater than a negative. Now remember that your absolute value is always going to give you, it will always give you a positive. So no matter what, every time from this absolute value, you're going to get a positive value. Right now, you are comparing that to a negative value. And the inequality is asking, is this positive going to be greater than or equal to a negative? And the answer to that, of course, is yes. So here's my yes on that one. It's always, this one's always true.
What?
Oh, spelling's hard.
What?
My bad. Oh, yes, it's always true. Always true. Yes, it's all, sorry, does this help? It's always true? Yes, this is always true because a positive will always be greater than a negative. It will never be equal, by the way, but it only has to be one or the other. Since this is always true, that means that any value of x would work. Down here, this is what the answer, something like this one. Now, the reason I pointed out, I did this kind of fast is because sometimes we get so programmed into being like, oh my gosh, we're going to break this up, and we're going to use principles of equality to solve this thing, and it feels so good, and we love it so much, right? But in the end, we just forgot to evaluate this. This is why we try not to be so robotic about this, as robotic as mathematics is. Yeah, compare your values. If you're comparing this to negatives, that should throw up some red flags right from the beginning. You shouldn't need to do any of this extra work right here. All right, we'll solve this one. It says the graph, so we will, even though I was going to, because it asks for integral notation. But again, that's for my benefit. Hopefully it helps you too. So let's go and take a closer look at this one. Now remember, you have to solve for your absolute value first before you start breaking things up into the two separate, in this case, inequalities. So let's isolate that absolute value, just like we would solve for a specific variable back in 1.10, right? So I don't want anything added or subtracted to my absolute values in this case. So add 7 to both sides to zero this out. Okay, so I'm going to drop my 11 times the absolute value of x. There's that one. Zeroed out my 7s. This will be less than or equal to 48 plus 7, 55. Oh, that'll work out very nice. Because now I will divide both sides by 11 to make that a phantom 1 there. Then I end up with the absolute value of x is less than, that was positive, so it's still less than or equal to now 5. Okay, so this gives me now an inequality that I can split up, which I will do. X could be less than or equal to 5. And by the way, this is not eating the absolute value. So you could make this a compound inequality, which I'll show you here in a second. And then also x could be greater than or equal to negative 5, okay? So the way that I do this, and by the way, that kind of completes the inequality portion of this, okay? But the way that I do this, if I see that it's not eating the absolute value, because unfortunately for me, I have the rules memorized. But if I saw this, if I saw the absolute value of x is less than or equal to 5, I just kind of copy this out on the left side like this, and then pretty much get rid of the absolute values. This is the compound inequality, and it's done right there, okay? So, I mean, you could put an and statement right here, but I believe on Canvas, if they do want the inequality, which I'm not sure that they do, they would want this one right here, okay? Now, if you don't see that from what I have written in green right there, I would hope that a graph would kind of help you see this now that we're going to do the graph, because it did ask for it. So x is compared with, there's my 0, with 5 and negative 5. And you could look back to the green here. So starting with 5, I see that it's a closed circle because it could equal x, and then it will go to the left. And then at negative 5, still a closed circle because it could equal it, and then this goes to the right. If we see with absolute value inequalities that they intersect like this, automatically it becomes an and statement right there. Okay, and now that you see this graph, if you needed this inequality, you should be able to derive it from just the graph. But of course, we still need the interval. So this one starts at negative 5, which is included, so square brackets, going all the way to 5, also included, square brackets, done. Absolute, oh, here we go. You know, you guys try this one out, okay? 1 minute. So on this one, I actually like this one because it's going to end up with a 1 value, right? So let's go ahead and solve this. And, well, principles of equality. We need to isolate that absolute value first. So let's get rid of that plus 9 by subtracting 9 from both sides. So that's going to zero that out. 13 minus 9 would be 4 right there. So now I have 4 times the absolute value of x is greater than or equal to 4. Okay? And then I'm going to divide both sides by 4. And you'll keep in mind, again, this is hypothetical, but if this was a negative 4 and you had to divide both sides by negative 4, you'd have to flip that inequality at this point. Okay? But it's not, so we're going to keep it the same. And so now I end up with the absolute value of x, there it is greater than or equal to, now 4 divided by 4 is 1. Okay? And this is good. Just keep in mind, if you saw, just like we've seen before, if this was negative by now, you'd be done. And you say, oh, if it's negative, it's always greater than a negative, boom, we're done, right? But it's not, so we got to split this up. So x would have to be greater than or equal to 1 first. And then you also have the other one, x compared with negative 1, just flip that inequality right here, okay? And so looking at this inequality right here, it's eating the absolute value, which means this would be an or statement. So I guess there's a need for it. You know, there's that one problem that we did where it's A or B, the or statement or the compound inequality. I believe if you see a problem like this on the test, then you would have to state it as an or statement if it asks for the inequality. This one does. Solve each inequality. So I'm gonna show this inequality just like I have it right there. And I don't really care if you put the negative on the right or the negative on the left. As long as the inequalities are true, that's the only thing that matters, okay? So that is the inequalities. Let's go ahead and look at what the graph would be like on this one. So right in the middle, 0, to the right 1, and then to the left, negative 1. Just comparing these. It is an or statement. So the first green statement, x is greater than or equal to 1. So that's, again, at 1, it's a closed circle because it could equal 1. It's eating the x, so the line goes to the right. And then the second green statement there, x is less than or equal to negative 1. So there's a closed circle. And it's not eating the x, so the line goes to the left. Finish this one off. Now we got the graph, and that was part of the problem. So now we just need the interval. This green line is going to go all the way to the left into negative infinity. It stops at negative 1. So for this one, negative 1 is included, and so there's our square brackets, and I will unite this. So there's my or statement starting at 1, which is included as well. So there's a square bracket going all the way on this next green line. It goes all the way to infinity, which is never included, okay? So if you look at this stuff, this is asking for 3 different parts, right? 3 different answers. It wants the inequality, it wants the graph, and it wants the interval notation for the solutions, right? So if this was a test, this is plenty of work. Not that you have to bring in colored pencils or pens, although that does happen from time to time, and your work looks really pretty like mine does, but even though the handwriting sucks. But that would be one answer right there. You can box it in. You could even box in the graph, although that's kind of a standalone right there, and then you can box that in. You see, I mean, that looks kind of messy. I'm going to make it more messy. You could just box the whole thing if you wanted to. And also on the exam, I'll need to see some work up here too, okay? I'm not saying you have to show necessarily all the work, but I need to see some work. All right, here's this one. These ones are so fun because it's done. Yeah, some of you guys are like, we got to split it up though. No, we don't. We don't have to, right? Well, what do you mean we're done? Well, it's comparing with the negative. So that's as far as we need to go right there. The question is, What would this be? Is that going to be a true statement or a false statement? Well, remember that the absolute value will always give you a positive right here. And we can see right there that the negative, well, it's negative, right? So this is right now saying that a positive is going to be less than or equal to a negative. Now, for one, it will never be less than a negative. And also, it will never be equal to a negative. So this one is just, I don't know, I like to show it as just always false, right? And you're welcome, if you'd like, to replace any value of x you want. You can make it super big, into the trillions, or if there is such a thing, quadrillions, Googles, I guess. Or you can make it negative, you could punch in decimals or fractions, and you will never find a value that would make this true. So on the homework, that's what it will want, is a D&E statement. It just does not exist.